This video is certainly overdue after the amount of times that I've heard people requesting me to explain it or requesting me to make a video about this, so here you go. My name's Lablemon and I basically just explain the body to you guys. Now shortly to my background, because this is my second YouTube video from sort of trying to move away from TikTok. I'm a student in my last semester of molecular biomedicine, and for those of you who don't know what exactly this is, it's a very broad subject and it basically just covers all of the research that is done in medicine. It's basically just everything concerning the body on a molecular aspect. It almost even crosses with chemistry. Now during the course of the video I will be talking about two specific medications. One of them is not even approved yet, but I've just heard too much about it and I feel like it's almost my responsibility as a creator, as a small creator that creates this sort of like medical content, to inform you guys what this is actually about. And the medication that I'm talking about is Retatrutide, which I've heard a lot about people that want to take it, and I'm going to explain this with the help of Semaglutide, which some of you guys have maybe even heard about. It goes under the name Ozempic, and I'm going to split the whole informative aspect into two videos. This video mainly focusing on the mechanism, the next video focusing on the clinical studies that have been done, the different phases, and why it's not yet been approved for clinical use, at least not in the EU. Funny thing, actually, I do have a poster in the background that I used for my last exam that explains how clinical studies work. Anyway, this is not important for you guys. I will be explaining it off this sort of concept, how Retatrutide is being clinically researched, and like I mentioned before, why exactly it's not been approved yet. Now, for those of you who don't exactly know what Retatrutide is, or semaglutide, what exactly it's used for, it is mainly used for people with type 2 diabetes or people in general that are obese or even morbidly obese, where health is simply at high risk. Now, first and foremost, before I even begin explaining the mechanisms, I will say if you're already at a healthy weight and only want to lose a few kilos, say for example 4 or 5 kilo, until you're at the weight you want to be at, these drugs are generally not what they've been designed for. When I'm going to explain the mechanism, you'll see what exactly I mean by this. They cause rapid weight loss in a very short amount of time. And if you're still in a healthy spectrum, this is not for you. The drug can produce far more weight loss than you actually need. And because the weight loss is so rapid, it can cause muscle loss, nutrient deficiency, gastrointestinal side effects, and other health complications, like I said, if you're already in a healthy range. Now, how exactly Retatrutide works, we're gonna have to understand how semaglutide works. Now, what normally happens is we take up food, the meal enters the stomach, it is partially digested, not all of it, and small portions pass into the small intestine. Now, these small portions of nutrients that pass into the small intestine stimulate enteroendocrine cells. These are cells that create hormones. Hormones such as GIP and GLP-1. Now, once these hormones have been created, they are released into the bloodstream. Now, for the context of semaglutide, we will be focusing on GLP-1 first. So what happens is GLP-1 is released into the bloodstream and binds to beta cells in the pancreas. So when GLP binds to the GLP-1 receptor on the beta cells create and secrete glucose-dependent insulin. Now, this is not the only thing that GLP-1 is able to do. What GLP-1 also does is it suppresses glucagon release from the pancreatic alpha cells. Therefore, less glucagon is able to travel to the liver. And this is important because glucagon acts as a signal for the liver to release glucose into the blood. Now, if no glucagon reaches the liver, no glucose is released into the blood from the liver, which causes the all-in-all glucose level to drop even more, which is important for diabetes 2 patients. Now, a further effect that GLP-1 also has is that it slows down gastric emptying, so food remains longer in the stomach. Now, this means that patients are less hungry, are satiated a lot longer and a lot earlier, have fewer food cravings, and all in all take in less calories. Now, the thing about GLP-1 is that it's not very long lasting. It lasts about 1 or 2 minutes and then rapidly decreases because there is another enzyme called DPP that takes apart the GLP-1, so degrades GLP-1 so that we have less GLP-1 in our body. Now, what the medication semaglutide does, or also Ozempic, is that it is like GLP-1, but it's a little bit alterated so that the DPP enzyme enzyme cannot bind to semaglutide and therefore lasts a lot longer, meaning about a week, which is why patients that do take Ozempic need weekly injections. Now, this is Ozempic's. Retatrutide is not just a single agonist, so doesn't just act as one single hormone, it acts as 3 different hormones, which is also why it's called a triple agonist. On the one hand, we have the exact same or similar effects that Ozempic has, as it's a GLP-1 agonist. Not just that, it does a little bit more than that. It's also a GIP agonist and a glucagon receptor agonist. Now, what GLP-1 does, I explained with semaglutide. GIP is another hormone that is released after eating, also in the small intestine area, as I mentioned before, and also stimulates insulin secretion. Now, what GIP or binding to GIP receptors does is improve the beta cell functions and improve insulin sensitivity, which moreover is also important for type 2 diabetes patients, as the cause for type 2 is usually a lack of insulin sensitivity. Now we have the third receptor, and that is our glucagon receptor. Now this is what makes retatrutide unique, because as I mentioned before, what normally happens is that glucagon production raises the blood sugar, as it's a signal for the liver to release glucose. So why activate it? Now, interestingly enough, what happens is when we activate the glucagon receptor, even though it's a signal to raise the blood sugar, it's not the only effect that it has. It also stimulates lipolysis, fatty acid oxidation, hepatic fat utilization, and thermogenesis. So in simple terms, it's not only that you eat less, but your body also burns at the same time. Burns more energy, burns more fat. So on the one hand, you have Ozempic that works as a appetite reduction medication and decreases sugar levels in the blood. Retatrutide, on the other hand, does the same thing, but also burns calories. Now, in case you're wondering, with the glucagon receptor activation, why it doesn't necessarily raise the blood sugar is because we have the GIP and the GLP-1 receptor activated at the same time. So there is glucose going into the blood due to the glucagon receptor activation, but the other 2 receptor activations are decreasing this at the same time. So it's sort of all working together. And like I mentioned in the beginning, this is not a medication meant for healthy people that are already in healthy range and don't necessarily need weight loss. This is for people that are at health risk because of their obesity or have type 2 diabetes, for example, that is linked to obesity. So yeah, that's the video on at least the mechanisms, clinical studies and studies in general. As I said before, I will be explaining in another video in the next video.